Hey, welcome back. In this video, we're going to talk about custom data types and how we can create a custom data type to hold our animation data for our runner Scarfy and for our hazards, the nebulas. We're going to use this custom data type so we can reuse code and eliminate copied code, thus making our code less error-prone and more efficient. Let's get started. Now, one of the ways to create a custom data type is by making use of something called a struct. Now, this custom data type can contain its own variables, and we declare a struct using the struct keyword. It looks like this. We use the struct keyword with our new data type name along with a body followed by a semicolon. Now, any variables that we want our custom data type to have will go inside the body, and we declare them just like we declare regular variables with a type, a name, and a semicolon. Now, because our custom data type is built up of other data types, we call these compound data types. So when does this come in handy? Well, we've already seen that we're starting to repeat some of our variables. For example, we have an animation frame rectangle for Scarfy as well as for our nebula hazards. We also saw that each of these has its own screen position, which is a vector 2, and each of them has an anim frame integer, a float for their update time, and a float for their running time. Well, we can create a struct that has variables inside of it that can store all of this information for Scarfy as well as the nebulas. This struct can hold variables inside of it for each of these properties. Whenever we give a struct its own variables, we refer to those variables as members or member variables. So let's jump into our code and create this new custom data type. So we're here in dasher.cpp and we're ready to create our new custom data type. We need to declare the struct, and we do so up here just outside of the main function. So we're going to say struct, and we're going to create our new data type called animData. Now we need to follow this with a body and a semicolon at the end. Now inside, we can declare our member variables. Now first, we're going to need a rectangle. So I'm going to declare a rectangle called rec. Next, we need a vector 2, and this will be for the position. I'm going to call it pause. Now, we also need an animation frame. This will be an integer, and I'm just going to call this frame. We need a float called update time. And finally, we need a float called running time. So now we've declared a new custom data type. It's time to actually create a variable of this type. So let's scroll down to where we've declared our Scarfy variables. And just beneath our Scarfy texture 2D, I'm going to create a new anim data called Scarfy data. And we can actually initialize Scarfy data with some values. Now, there are a couple different ways to do this. For one, we can take our Scarfy data and we can access its member variables with the dot operator. So we could access the rectangle by saying scarfydata.rec. Now, scarfydata.rec is a rectangle, and rectangles have their own member variables. Remember, they have width, height, x, and y member variables. We can access those individually using the dot operator, so we can say scarfydata.rec.width, and we can assign a value to that using the assignment operator. Now we know the value that we would like this rectangle to have because we've already created this rectangle called scarfyrec and initialized its width with scarfy.width divided by 6. So we can copy scarfy.width divided by 6 and paste it here, assigning this value to scarfydata.rec.width. Now, just like we accessed our rec.width, we can access scarfydata.rec.height as well, and we can assign a value to that. Now, we set scarfyrec.height equal to scarfy.height, so we can use scarfy.height to initialize the rectangle rec that belongs to our Scarfy data. Now, our scarfydata.rec also has an x and a y. So why don't we assign values to the x and the y? For x, we're going to use 0 just like we did with our scarfyrec.x. We can do the same thing for y as well. So we're going to say scarfydata.rec.y equals 0. So now that our AnimData variable called scarfydata has its member variable called rec initialized, we can now look at the other member variables in our AnimData struct. The next is a vector2 called pos. Let's initialize that. So we know our scarfydata has a member called pos. We can access it by saying scarfydata.pos, and we can access the members that belong to this vector2 called pos by using the dot operator. So let's access this pos member variable and initialize its x. Now what do we want to initialize it to? Well, if we look down here where we created a vector2 for Scarfy's position, we initialized its x with the window width divided by 2 minus scarfyrec.width divided by 2. Well, we're not going to use our scarfyrec rectangle anymore. We're going to use the rectangle in our AnimData variable, so we can initialize scarfydata.pos.x to window width divided by 2 minus scarfydata.rec.width divided by 2. And now we can initialize scarfydata.pos.y. Now, if we look down to our vector2 called scarfypos, we initialized its y with window height minus scarfyrec.height. But again, we're not going to be using scarfyrec anymore. We're going to be using scarfydata.rec. So let's use that here. We're going to initialize scarfydata.pos.y to window height minus scarfydata.rec.height. So now we have an AnimData variable called scarfydata, and we've initialized its member variable called rec, and we've initialized its member variable called pos. Those are rectangle and vector2s respectively. Now scarfydata has some more variables. It has an integer called frame, a float called update time, and a float called running time. Now we can initialize these as well. Let's initialize scarfydata.frame. This is going to be the animation frame, and we'll start this off at 0. We can also initialize scarfydata.updateTime, and when we initialized our float called updateTime, we used a value of 1.0 divided by 12.0. Let's go ahead and use that to initialize scarfydata.updateTime. And finally, we can initialize scarfydata.runningTime, and we're going to give this a value of 0.0. So now we've initialized all the values of our AnimData that we called scarfydata. So in summary, we've created our own custom data type called AnimData, and we gave AnimData its own member variables. We then created a new variable of this AnimData type called scarfydata, and we initialized scarfydata's member variables by accessing them using the dot operator. I'll see you in the next video.